Hello Math 1 class. Today we are going to do section 3.3 features of function MVP math curriculum, and we are going to do two questions from the ready part. The first part, the ready part, the first question, it talks about fill in the table of values for each of the linear functions. Then circle the point of intersection. You have to find the point of intersection of the two lines in each table. So let's start with the very first problem. We have been given two functions here, f of x and g of x here. So for f of x, for this one and g of x, we have to create the table first, and they have given us 0, 1, 2, 3, 4 as x values in both tables. So what are we going to do? We are going to evaluate the function for these values. So here for this one, I'm going to get f of 0, I'm going to get f of 1, f of, let me make it bigger, I'm going to make f of 2, f of 3, f of 4. The function is given, it's all about evaluating. I will be finding out f of 0, f of x is given 3x minus 5, and what we have to do, it's just a substitution. This x is going to be replaced by 0, 1, 2, 3, 4 and so on. So f of 0 is 3 times 0 minus 5. 0 minus 5 is minus 5. Then f of 1, 3 times 1 minus 5. That's 3 minus 5, negative 2. F of 2, 3 times 2 minus 5. And that's 6 minus 5, that's 1. F of 3, that's 3 times 4, 3 times 3 minus 5, 9 minus 5, that's 4. And f of 4, that's 3 times 4 minus 5. 3 times 4 is 12, 12 minus 5 is 7. So we got the values and we are going to enter those values. So I have shown this work over here. If you can do it mentally, you do it, you don't need to, but it is for those who need to understand how I got these values. Negative 5, negative 2, and that's 1, then it's 4, and then it is 7. So we got our values. Let's move to our second table. We have to do the same procedure. We have to get for g of x. So g of x is what? It's given here as x plus 1. I just write it down, x plus 1, and I have to now find g0, because here our g0 will go, g1 will go, g2, g3 and g4. These values are going here in the second column. So I will find g1, g0, that's 0 plus 1. I substitute x as 0, that's 1. g1, 1 plus 1, that's 2. g2, that's 2 plus 1, that's 3. g3, that's 3 plus 1, that's 4. And same way g4 is going to be 4 plus 1, that's going to be 5. So we got our values, we are going to enter that. So here we are getting 1, 2, 3, 4 and 5. So we have to basically we have got the table, and we have to look for the point of intersection, and point of intersection is something like a point in common, a point which is common to both. So what we are going to do, we are going to figure out the point which is common to both. So when I look at it carefully, I see the point here, this 3, 4 and 3, 4 is common in both. So I can say point of intersection is what? Point of intersection is 3, 4. That's my answer. You have to look for a common point. So let's move to the next question, question number 2. So I hope you get it, how to evaluate it. For 2, I'm just going to directly substitute the value. So they started If I start with question number 2, what they did, they basically used the x values as 0, 1, 2, 3, 4. So we are going to do the same thing. So let's move to our other table, that's 0, 1, 2, 3, 4. Now we are going to get the f of x values, and here we have to just substitute here this x by different values. I have to replace it by 0, 1, 2, 3, 4 and get our second column. So when I plug in 0, I get 2, next I get 3, then I get 4, then I get 5, and I get 6. Same way for g of x, our function is 2x. So in this x is going to be replaced by 0, 1, 2, 3, 4. Once I replace it, I get my corresponding g of x values, and that's going to be 0, 2, 4, 6, and 8. So that's my table. Now I have to find the point of intersection, and how to get the point of intersection. Always look for the common points. So when I look for it, my common point could be this one. I see 2, 4 is here and 2, 4 is here. This is the point which is on both the functions. So my point of intersection is 2, 4. All right. So that's the way you do the remaining questions here. I hope you get it. If you don't get it, please leave a comment in the comment box. I'll move to the next part. Question number 11 to 14. I'll pick few questions here. So if I talk about this question, I forgot to use at the question instruction part. Basically, you have to find the domain here in these questions, and you have to use the interval notations. All right, interval notations, you have to use that. Let's move it, and we're going to start question number 11. For question number 11, so we have 3 parts here for the domain, and we need to look that the 3 chunks or pieces. For question number 11, we have this is the first, and we need to look for the domain. And domain, I told you, whenever you have solid circle, if you have solid circle, for that, let me write it down here. If you have solid circle, then that's a closed one. You use this kind of bracket over there to show the intervals, and if you have an open circle, then you use parentheses to show the interval. And if you have arrows, like you see any end or anything is having an arrow, it means it keeps on going, it's never ending. So you will be using, in that case, in plus minus infinity. Okay, and how is it? Like if you see this graph, the right hand side, it's going to be infinity, plus infinity, here negative infinity, here is plus infinity, here is negative infinity. So this way we can get it. So you just need to remember these things. When I look at it, both are closed ends for this part, and it starts here and ends here. And what are the readings? This is -4 and this is 0. So -4, 0, but we have to think about what is going to be the domain for the brackets or this parenthesis. What should be used? Because it's a closed one. It is the closed one, means we need to use the square at both ends. That's the one domain. Let's move to the other one. If I talk about this one, both ends are closed, and so it means it is going to be a square bracket, but it is starting at this point is what? This point is 1, and it's ending here. This point is 3. So my domain is 1, 3. Same way, if I have to do for the third part, so that third piece, it starts at here, that is 4, and ends here, that is 5. So it's going to be 4 and 5, but what kind of bracket? Because both ends are closed, so it's going to be closed bracket, okay, the square bracket. So that way we have three values for a domain. And if I look at the 12th question, number 12, there I see for this one we have a line, just a line, keep on going, and you have to be careful that it has this arrow at the end. It means it has not a fixed starting point and not a fixed ending point. It keeps on going. When it keeps on going, and I have to talk about domain, so domain says it's going to be covering this whole x-axis. It keeps on going on both ends. It's right side it keeps on going, left side it keeps on going. So on this side it's negative infinity, this side is plus infinity. So in that case my domain is going to be, because we don't have any fixed point, so that's it's going to be open circle, because we don't see it keeps on going, and that's negative infinity and infinity. That's the answer for this. Let's move to question number 13. If I go for that, you can pause the video and think about it and write your answer. So let me share. We have to write the domain, we need to see which part it's covering the x-axis. So I see it's here to, it keeps on going to this side, and it's never ending on this side. It keeps on going. So I don't have any ending point there. And also, so if it doesn't have any ending point for x-axis, that side it's in negative infinity. So domain is negative infinity, comma, and here this open circle belongs to this reading, and that reading on number line is 3. So that is 3, but that's an open circle. An open circle means you have to use a parenthesis, okay, a round one, this one. And the left hand side, that's negative infinity. So if it is, whenever you're using infinity, so that is never included, it keeps on going, so you always use the small parenthesis. And also make sure whenever you're writing the domain, the smallest number will be written first and then the greatest one. Let's look at the very last problem of this lesson. If I go to this problem, I see in this graph it has a starting point but with an open circle, and that corresponds to this origin, that's 0 actually. And when I look at the other end, it's not stopping, it keeps on going. So it means this side is infinity, positive infinity. So it is having 0 and infinity, but let's see how to create the brackets. But it is open circle on the left hand side, so it's going to be like this, and right hand side it's infinity because that keeps on going, so it's an open interval or the parenthesis again. I hope you get it. Please make sure you subscribe the channel so that you don't miss any other video. Thank you so much for watching. Stay safe. Bye.